Hello, F-sharp. Welcome back. Let's continue our journey of learning the features of the F-sharp language. Now, today what we're going to talk about is modules. And modules are one of the tools that we use to organize our code in F-sharp. Up till now, we've been talking about very small pieces of code, things like record definitions, struct definitions, primitives, integers, strings, or functions. And those are really the fundamental units that we use to compose solutions in F-sharp. Now, what do we do when we want to start organizing those pieces in sensible units? Now, in F-sharp, what we would use is a module. And I'm going to show you how to define a module. And in a future series that I'm thinking about, I'm going to have the F-sharp internals, which talks about how F-sharp features actually map down into IL, the intermediate language of .NET, and then from IL down to assembly. That's going to be for a future series. So you don't need to worry about how exactly this works right now. I'm just going to expose you to the feature and talk you through how I use it to organize my code. Now, there's a couple different ways to define a module. One way is at the top of a file. So you could say in an F-sharp file, say, hey, module, my module. And then you can start putting in type definitions and functions inside of your module. So we could define a type. So I'm going to do the most common thing that I always do, which is a chicken. And it has a name, which is a string, and a size, which is a float. So inside of this module, and if I hover over this, the type inference is saying, yep, you have this module, and its name is my module. And you know what? I'm going to go ahead and rename this, and I'm going to rename it to farm. And that'll make sense later why I'm renaming it. So I have this module farm. Inside of it, I have a type definition, which is chicken. I can also define functions inside of a module. So let my adder, and this is going to take an A and a B, and it's going to return A plus B. And so inside of the farm module, I have also defined a function, which you can see here, that let my adder. So that's one way. Another way you can define a module is you could say, you know what? I want to have a module inside of another module. And what you can do there is say like, hey, module chicken, and this is where we would put functions for working with chicken, right? So let's say grow. And this is going to take a C, which I'm going to say this is a chicken. And it's say, okay, this is going to return C, but I'm going to say size equals C dot size plus 10. So it'll take in a chicken, and then it will return a chicken, but the size value has been increased by 10. So one thing you might notice here is that when I define this top level module at the very beginning of my file, I did not have to have this space equals. It's unnecessary when it's at the top of a file. When you're nesting though, so this module is actually nested inside of the farm module, you do need to use this equal sign, and then the contents of your module are going to be indented in. This type definition and this function are on the same level of indentation of this top level module. And we can do that because this module definition is at the very top of the file. And so implicitly, everything in the file is inside of this module. But when I'm defining a module that's nested inside of another one, I need to use this syntax with the equal sign, and then its contents is indented in. If I unindent it, it's thinking that grow is going to be a part of the farm module, and there's nothing inside the chicken module. So that's one of the things that kind of tripped me up early on, was like, okay, I'm like a module inside of another module. Like, what am I doing? And you could even do something said like this, like module chick, like a baby chicken. And I could have, let chick adder, I don't know, this is something ridiculous, but this is just another, and I'm just going to, plus B equals A plus B. An absurd function, I know, but I'm showing you this module is now nested inside of this module. So We can kind of just keep nesting them if we want to. I don't suggest that you do that, but you certainly could. Now, okay, I'm organizing my functions in here. How do I then use them? If I want to use a function that is inside of a module, I could just use it from inside the module. I could define a chicken in here. So like a chicken, and I'm going to say like, hey, name is equal to a, size is equal to 1. And I have defined. And so what the type inference is doing now is saying, okay, I see you have this record. You're creating an instance of a record, and the type inference is kind of looking up to say like what record is in scope that matches this definition. And the first one it finds is chicken. So it's assuming, oh, this must be a chicken. And I could use this grow function here right now. So I'm going to say let be chicken equal grow, and I'm going to give it a chicken. And that would work because when I define this function, it is in scope for everything inside this module, and it's in scope for all the child modules as well. And that's why chicken is also in scope inside of this chicken module down here, because the module is nested. And so all the types and functions that were declared in the parent module are available in the child module. Okay. Now let's say I want to use the grow function, but from outside of the chicken module. I want to use it somewhere outside of it. Okay, I'm gonna get rid of this nested one and unindent. A chicken still works because, hey, I'm still defining a record. It's matching against this chicken type up here. But now grow, my call to the grow function is not working because grow is not in scope at this point because I'm one level out from this chicken module, but I would like to use this function. So how would I do that? Well, there are two things that you could do. You could say like, you know what? Chicken.grow. And what it is doing is like, okay, well, the chicken module is in scope and it has a function inside of it, which is called grow. And so, yeah, I will use that. And so that is how I can access functions that are inside other modules. Now, something I want to point out here, which might be confusing. I'm using the term chicken here all over the place, and I'm going to change this a little bit just so it's easier to kind of parse out which chicken are we referring to. So right now I'm going to change this to chicken type. And then I'm going to have chicken module. So I have the type, which is chicken, and then I have a module, which is for working with functions of chicken type. And here I am, I'm being very explicit. I've given them different names. So I have the type name and I have a module name. It is very common in F# to have a type and a module of the same name. And when that happens, the general understanding is that if you have a module with a name that is the same as a type, the contents of that module is functions for working on that type. Now, I'm going to change this back, but I wanted you to see that where I'm talking about the chicken type and where I'm talking about the functionality inside of the chicken module. I'm going to undo that. But as you write more and more F#, like this pattern, you will see this kind of over and over and over again, and it will make sense and you'll come to expect it. But again, that was one of the things that was a little confusing to me at the beginning. It's like, okay, well, you have the chicken type and you have the chicken module. I'm confused. Yeah, it's completely understandable. But the compiler is smart and knows like, okay, here you're wanting to create an instance of type chicken. Here you're wanting to call a function that is in the chicken module. Those things are not actually conflicting with each other. And so this naming convention is very common. Now, this is one way to access the grow function inside of this module. There is another way. What you could do is say, hey, open chicken. And when you do that, what you just did is when you say open chicken, this is the chicken module, is saying like, hey, make all of the functions inside of this module available in the scope below me. So now when I'm calling grow, the compiler is like, oh, well, you've opened up the chicken module. Therefore, all the functions inside of this module are now available to me in this scope. You could certainly do that. And I will discuss shortly where I find that valuable. I generally discourage this. And the reason, and I actually encourage the opposite of it. What I like to do is instead of opening it up, what I like to do is say like, no, quite the opposite, require qualified access. And by putting this attribute on the module, it's saying you are not allowed to open this module. You cannot go open chicken. That is unacceptable. Now you might be thinking like, Matthew, that's kind of a hassle. Why would you do that? Let me show you. Let me show you why you would want to do something like that. So before, I'm going to get rid of this myAdder function because it's ridiculous. We don't need it. Before we had this type chicken, and then we had functions for working on chicken. I'm going to go ahead and fix this so the compiler is not angry at me. It is entirely feasible, given that we are in the farm module, that there may be other types, right? There could be a type which is cow. And it too has a name, which is a string, and I'm going to say it has an age. And I'm going to say it's integer. I'm just making the shape of the records different, that's all. And it is entirely possible that I would also have a cow module. And it is entirely reasonable that there would be a grow function inside of there as well. Now what happens with age equal to cAge plus 1. Again, I know these are ridiculous functions, but I'm just wanting to like work through syntax with you. It is entirely possible that I would have types with associated modules with very similar names. This happens all the time for me. Typically, it's not a grow function. Typically, it's a create function because like, hey, I'm always wanting to create instances and maybe I have some domain validation that I want to do inside of that create function. And so this happens all the time. And so now if I didn't have this require qualified access and I had a, open chicken and then open cow, it'd be, and let's get rid of this. Now we're going to get this compiler error saying like, hey, you're calling grow on a chicken, but I'm expecting grow a cow. And it's and again, this is the confusion that I had early on as a developer is like, how does it not know? How's it getting confused? Because I'm like, hey, there's this grow here. And I didn't realize like this second this opening brought this grow function into scope. And this grow function was shadowing this grow function. It got very confusing. And you might not think this is a big deal early on because, and again, this was very true of me as an F# developer. I was working with very small domains, very small projects, and fewer numbers of types. And so I didn't think that this was a big deal. And so I didn't put in as much effort to keep my domains clearly separated and clearly defined. Because when it's small, it's relatively easy to keep all that scope and context in your head. As the complexity of the solution grows and the number of types grow, it is much more difficult to keep all that context in your head. And then let's say you've written some code, 6 months go by and you're coming back. You probably don't have any of that context in your head again, and you need to kind of reload it. And so I might be harping on something that you think is not a big deal, but I'm letting you know that as you mature as a developer and as you write more F# code, this will end up saving you a lot more time just in terms of debugging and understanding your code because it's explicit about what it's calling and what it is doing. And so, like I said, I would strongly encourage you away from that. I'm not saying it's wrong. I'm just saying you'd want to be very careful and purposeful about it. I would much prefer to see something like this where you have require qualified access on these, so that now when you call grow, you're having to be very explicit about which one you're using. It's like, yes, I know I'm using the chicken.grow here. And if you feel like this approach is onerous and takes more time, there are other ways of modeling and working with these that can make it more straightforward. But we're talking about modules today. So when it comes to these modules, I strongly encourage you to use require qualified access in places where you know you're going to have multiple modules with functions of similar naming structure. And that way you can avoid the difficulties that will come when you start opening up multiple modules and then like you have all this collision. So we've defined a top level module. We've talked about nesting modules inside of one another. We've talked about adding require qualified access so that we're not dealing with conflict and bring other things into scope. There's one other thing I wanted to mention about modules. And sometimes you will see something like this. And I'm going to say my awesome game. I don't know, I'm just coming up with something silly. You'll see this kind of definition at the beginning of an F# file and say, okay, well, what's going on here? So your module is still farm, but this part at the beginning, this dot before, this is defining the namespace that it belongs to. And so it's, again, like a way of organizing your code, saying like, okay, well, as the complexity of your solution grows and you're having more modules, you'll want to organize those things into namespaces. And so like, yeah, you know what? I want this farm module to belong to this namespace. And so that's what this piece is here before the dot. And you could have it more than that. So like my organization, again, these are all part of the namespace for the module. You will also possibly see cases where the namespace is just explicit like this, space, and I'm going to go ahead and cut that and bring it to the top. And now what happens when you do that, now you're going to have to use that syntax I mentioned before where you're actually going to have to put the equals and tab things in. So you might see some code like this where you have the namespace declaration up here and then a module. But then when you do this, now you're going to have to use that equals and then indent all the contents of that module. So that's why you typically won't see that. You will typically, well, I don't know. It depends on your organization, how you decide to organize your code. I typically do this where I'm like fully qualifying that namespace and then I'm saying like, hey, here's the name of the module. So that's a really quick introduction to modules in F# and like how we can use them to kind of organize our types and our functions and put them into kind of blocks of related domains. Later on, I'll talk about other ways that we can. Okay, well, there's one other thing I wanted to hit. So before we go, inside, let's say inside of this chicken module, I had some additional functionality that I needed to support. And this is the function that I want to expose to the outside world. Now, I often do something like this where I have module private helpers, and then I have again, I'm putting in just a dummy function here, a, b equals a plus b. And then I will open helpers. And so why would I do something like this? So grow is a function I want exposed to the rest of the world. I want it available for other people to use. But let's say the grow function had, more complex code here, where it's having to do something much more sophisticated. Instead of letting grow become this very large function, what I will often do is put that additional complex business logic in a nested module called helpers. You can call it anything you want. I often call it helpers because it's kind of like it's helping me do the work of the module. I make it a private module so that it's not accessible to the outside world. So someone can use grow, but because this module is private, all the functions inside of it are not available. And then I will use an open helpers in this case, because now I'm bringing these functions into scope for the purposes of my functions, but it's not going to be available to anyone else. And so this is a case where I like to use the open. So when I'm exposing things to the outside world, and I know that I will have multiple modules with the same function name, in this case, grow, I will put require qualified access on that so as not to cause ambiguity in the person consuming or using the code. But internally, in restricted contexts, I will do this, where I say, like, I will define these kind of private functions that are only supposed to be available in this context, and then I will use an open. The reason I do that is because I don't have a problem with having long functions. I'm not one of those people who's like, if a function is more than 6 lines, you're doing it wrong. I think that's absurd. But I do like to keep functions relatively focused, I think is the way I will put it. I like them focused on solving a particular problem. And so it's very nice to decompose functions down into kind of the individual operations or the individual ideas. But you don't want to expose them all to the outside world. You don't want to have to make that available for everyone to see. So only expose what you intend for people to use. Hide more sophisticated logic inside of a private module, and then go ahead and open that to make your life easy. So that's all I really wanted to talk to you about today when it comes to modules and how to organize code. I hope you found this helpful. Something that would be helpful for me is if you left some feedback on what it is that you would like me to review in the F# code base, in the F# language, and some problems that you're struggling with that you would like to see me address. Things that you would say like, Matthew, I was really having a difficult time with arrays or lists or some other feature. And if you provided me some code, I'd be happy to unpack that for you. And I guarantee you someone else is also having that question. So it would really help me help the community if you let me know. Thank you very much and have a great day.